So once the door closes so that it's kind of quietly here. And yeah, cool. Thanks, Mark. Please go ahead.
Sure. So thanks everybody for coming. I'm really excited to be talking today, and I'm going to take everything down to sort of, I think, the core base origins of programming, at least as I think about it. And the first question I want to ask is, what is the purpose of a programming language? What is its role in software development? Well, sort of early on it was, I have a program and I need to express it in a way that I can execute it on some physical hardware, right? That's obviously a very important thing. Or, if I'm a formal methods guy, I can convert it to some mathematical model and reason about it. So it's a means for expression to some formal or mechanical system. In modern software engineering, I have a team of 40 people or a distributed project. It's a means of communication with other humans who are also working on the program. And of course, recently everybody's very excited about ChatGPT. Well, now it's a medium for an AI agent to, in whatever way it's come up with writing an algorithm, to express what its solution is or its candidate solution is to me, right? And then also, well, that AI agent's going to be looking at my code to try and understand what I want, and so it's going to be trying to reason about it. And so I kind of segue there. Well, what's common about all of these? There's some system that's looking at this programming language artifact and trying to reason about what it means. So, in a sense, it's a little tautological, but fundamentally, all of software development is a problem of reasoning about the meaning of some chunk of code in some context. And, how do we build a language, or how do languages support this reasoning? And it's a broad audience. They're humans, they're automated developers, they're these AI systems now, compilers, like, what do programming languages do that support this? And, kind of the first part of this talk, what are things that programming languages have that are maybe anti-features, that maybe come along for historical reasons, but on some fundamental level just make it hard for us to understand what on earth is going on with a bit of code. And so I'm going to sort of break it down. I have these categories. So let's talk about automated reasoning and symbolic analysis of code. This has been a topic of programming language research ever since programming languages were invented. And over the years, we've seen, at least in my experience, kind of a couple of common themes that come up here. Loops and inductive invariance. Anybody who's ever done program analysis knows that life is all good when you have straight line code, but when you have loops, suddenly things become, well, less fun. Mutable state. Everybody loves frame rules and invariant analysis and aliasing and all this sort of stuff. And then identity and equality, right? Do two objects point to each other? If I mutate one, does it change the other? Are these things, what is the structure of this object graph? These are just huge, long-standing research problems. I mean, dating back 40 plus years for each of these. And, a lot of great work in this area. I've done work in this area. I know there are papers here this week in this area that are improving the state of the art, but, the current state of the art and where I'd like to be and able to really reason about hundreds of thousands of lines of code effectively is a big delta. And I think these might just be foundationally hard problems. And, it's a challenge. So humans are much better at dealing with a lot of these things because we don't go and look at every little detail. We kind of make broad assumptions about most likely things that are going to happen. So that makes us really good at dealing with, loops and code that might mutate stuff, because we just make assumptions that it probably doesn't. And, that means we do pretty well, but oftentimes if there are these unexpected things, non-determinism, surprising behaviors, they can really throw us for a loop and cause us a lot of grief. I mean, if I log something to, log4j, why would it go on the internet, download code, and execute it untrusted? That would never happen, right? Like, log is just to put my message in some stream. So, these things can really blow up. They're simple in hindsight, but, nobody knows every line of code of their million line of code application, so it gets us. AI agents are they're an interesting intermediate point because they understand a lot, like they've seen all the code on the internet, right? But they are only going to look at and understand a piece of code based on its syntax. They don't have an understanding of the semantics of a programming language, right? Or the specific semantics of your application. And so this means they can sort of hallucinate unusual things, or if something is, in your code but hasn't been in their training set, they're not going to know what to do with it. So, a funny example I have is I saw a great demo. Someone was using ChatGPT 4 to do calendar scheduling with Google Calendar. And so they said, oh, I want to schedule a meeting tomorrow. And it goes and it generates all of the right, RESTful API stuff, the JSON objects, everything, and it has to pick a time for this meeting. So what does it do? Well, everybody who's done a tutorial for how to use Google Calendar just sticks in 10 a.m. So it thought picking 10 a.m. as a constant meeting time was great. I'm in Europe, you're busy at that time, but 10 a.m. So it doesn't have this notion of common sense that I should check availability before I do these things. So they kind of, they have this funny, if it's not visible in the syntax, or it hasn't been in their big training set of all the code, they just don't know about it, right? So they kind of have these blind spots that they don't know what to do with. So the takeaway is, I think reasoning for all of these agents is hard. Now there's some sources that are common, right? Like, mutability and is difficult for everybody, but different agents have different bits of struggle there. And at the end of the day, the inability to effectively reason about what this code is doing has real costs, both it makes my life less fun because I got to deal with this, but real money costs to big businesses. Like, it slows down development velocity. If I have to look at a method and then I have to go and F12 over to some other code and then F12 over some other code and spend 30 minutes trying to figure out, does any of these mutate global state, or can I make this assumption? That just slows down my development velocity, requires bigger teams, right? It prevents the deployment of really powerful tools. There have been great demos of incredible things for bug finding, but deploying them at scale is difficult because they just don't scale to these big code bases. Compilers can't do all sorts of optimizations that they'd love to do. It increases errors and risk, log4j, huge amounts of money lost because a simple reasoning oversight in the code. And it excludes non-experts. Like the talk before was great about how complexity and some of these subtle semantic things really make it difficult for someone who's more of a citizen developer to use these tools effectively. So what's the vision of this talk? Well, hopefully I convinced everybody that we have some anti-patterns here that we could probably do better about. So it's, how do we build this software stack that's optimized for reasoning? Like, I want to go back to the ground level and look at programming language design from the bottom up and say, for every choice I want to ask, is this just a historically convenient choice, or is this choice going to be something that makes it easy to reason about this code, and can I get rid of it if it's something that is not absolutely there and causes some problems? And so kind of the funny thing in this talk is, I'm not going to tell you a cool new programming language feature or an amazing new analysis technique. I'm just going to say I'm going to make things as simple as possible using existing ideas and technology for the most part. Like, I don't want to solve the problem of complexity by adding more complexity. So we're just going to go back to the basics here. And so we're going to say, well, let's look at our core IR. The Bosque language that I've been working on consists of a core IR and then a surface syntax. So for the core IR, it's mainly focused on supporting automated reasoning, not surprisingly. And we're just going to eliminate some things that cause us lots of grief. So it has no loops. It's just going to use higher order functions instead. All values are immutable and referentially transparent. Just simple if-then-else based intermediate representation, so compiles down super well to all sorts of reasoning tools. And an important thing is that's fully determinized semantics. So that's not only is there no undefined behavior, but things like the enumeration order of a map or the stability of a sort is always fixed. So you never have to do your funny case split, gobbledygook and consider an exponentially increasing number of options. The other thing that we really put a lot of effort in is in making implicit information explicit, right? So if I'm writing an analysis, I want all sorts of useful information to be immediately available in local context and not having to do lots of global interprocedural analysis and hunting and pulling in information from all sorts of places. So everything's strongly typed, including primitives. We put a lot of data invariants and everything so you can understand what is true at any given point in the code, and you know what things are definitely not going to change. It's very obvious. Now, it's very easy to go and create a programming language that has no bugs ever written in it because no one ever writes a line in a code in it because it's so miserable and painful to use. So the next challenge is, well, maybe I have a language with a core that's very easy to reason about for an automated system, but now how do I connect that core to a nice surface syntax that's very friendly for these human and AI agents? So, it has to be a full programming language. It can't just be a DSL. Like, you should be able to write whatever computation you need in this language. We want it to be very approachable for a modern dev coming from sort of this, line of business, IT industry, small, medium enterprise development space. So I'm a C# developer, a TypeScript developer. I should be able to look at this code. It should take me a couple days, max a week, to be up to speed in using this. Shouldn't be any clever and deep knowledge of proof languages or special semantics or theorem provers required to use this. Like, I should just be able to come in as a somewhat skilled developer and be productive and happy. And so we really did a lot of work to connect things that developers seem to be very attracted to. So like block structured syntax with variable reuse, adding things like typed strings to eliminate a bunch of stringly typed APIs to make it very easy for these types of developers to express their intent clearly and simply. And then we use some clever compiler techniques to connect these down to that nice core IR. So let me just show you a couple samples so you can see. So here's an absolute value function. As you can see, this is almost perfectly legal TypeScript. It has a nice block structured syntax. It allows variable reassignment. So if you were to ask most TypeScript devs write abs, they'd write something exactly like this. So they'll be very happy. Instead of loops, we have these higher order functors, which allow you to just, say all of to map a predicate over all of something. We're a little careful with lambdas. So for example, developers get very confused when lambdas start getting passed up and stored in locations and passed around. And empirically, people have shown that about 95% of all lambda uses are in, a primary argument position. So this way, we force that, in the compiler, and then we can compile them out, and everything becomes first order and super easy to analyze on the back end, and prevents a bunch of confusing software for our devs. So I'll just break down a couple of examples of some stuff in the Bosque language that we do to make it, easy to reason about, both on the front end and the back end. So here's block scoping. We have our abs function. As I mentioned, it has, multiple assignment in here, and we want to have a pure functional back-end language. So the nice thing is we have no loops, so it becomes very nice or convenient to do a dynamic single assignment form. We just rename all the variables, put a phi function in there, and now we're just, with a little bit of syntactic magic, we're back to our pure functional let-based language, right? We have a little feature called ref methods that allow us to fake mutability at a single variable level, so we don't get into a bunch of aliasing and mutability, but users can write nice stuff where they want to, say, intern a string in some table and be able to process, through data repeatedly. So they can write this ref method, which is basically going to take the argument and mutate it in locally, and then on the return, do the tuple return and do all the unbundling for them. So then you can write some code that says, I have this environment, I call intern string hello, and I'm going to get name ID 1, but I'm going to implicitly update the environment there. I name ID 2, implicitly update the environment. And so I can write this sort of natural imperative style code in the very common case, but prevent it from becoming that, very complicated to reason about thing where I have mutable graphs of references going all over. Another one which has seen a lot of popularity with developers we've worked with is type strings. So especially in the cloud programming space, you have these, what I call them stringly typed APIs, because the only thing everybody understands is byte arrays and strings. And so you'll have a method foo that takes arguments string, 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 right? And you're like, well, good luck swapping them or guessing what they are or guessing what the legal values are. And so this allows you to say, I'm going to have a regex that is a zip code US. And now I'm going to write a method that takes a string, which is a string of zip code US. And this is actually now a typed object. And we do the regex validation as we go. And so you can call this method, and it'll check that the string literal conforms to the regex. And there'll be a compiler error if it doesn't. But then also if you have string literals of other types, these will also be string errors. And we can do all the parsing and validation for you. So this is a really nice way to make this implicit information that appears in a lot of these stringly typed APIs very explicit, both for the programmer to immediately understand the intent, but also for the analyzer to then be able to say, oh, if I want to do fuzzing on this method, I'm not generating random strings, I'm generating strings that conform exactly to this regex, and I can be much more effective in the tooling space as well. So this is a nice synergy where features that make it easier for the developers to express intent make it easier for our tools to key off that and generate better results, making it developers more likely to want to express their intent, right? So we get kind of this virtuous cycle going. In a similar vein, we provide built-in support for like requires and ensures on functions, and of course invariance on data types as well, right? This is one of the things that brings a lot of value. So I sort of talked about the language a little bit. We've been working on this for several years, and I claimed that this is better for automated reasoning and these other tasks. So one of the things I've been doing is building a couple prototypes of this to kind of validate this. So let me show one of them. So this is kind of goes and says, I want to build a small model verifier. And that is, for any possible runtime error or user assertion or invariant with arbitrary predicates that they've written there, I want to either be able to generate a witness that triggers that error and then go and actually construct the concrete input that will cause that crash, so I can open a bug report in your GitHub repo, and the developer can go act on that information without having to understand the prover or traces or anything. It's just the same debugging experience they know and love. Or prove that there's no small model that'll generate it. And by small model, I mean input collections with like 5 elements or less. And this is kind of conventional wisdom that, hey, if there's no small repro for your bug, like it's going to be tough for us to fix it. It's going to be a lower priority for us. And empirical studies indicate that this is a pretty common property. So this was a good sweet spot for us. So as you might guess, if anybody's familiar with doing SMT encodings for languages, the way I describe the language, it's actually very simple, and it matches almost one-to-one with the SMT theories you have in a solver like, Z3, right, which is the one I use. So a lot of the primitive values map directly across. All of the data structures go into the theory of constructors, and since we have a finiteness on the collections, they map to sequence. These are all decidable fragments, so we actually have a decision procedure, and Z3 is very good at these particular theories, so it's quite efficient. Just for those of you who aren't so familiar with this, let me just show an example. Here's our absolute value function again, and then here it is in SMT-lib, so you see it almost goes directly across. So we can throw this into Z3, it churns away, builds a model, comes up with an unsat core, all good fun. So here's an example of it running. This is a little tic-tac-toe game. You can see I'm going to set a cell mark, and I want to make sure that it's empty before I place a piece there. I have a little test file that has classic unit tests. Also has some of these property-based tests where I'm just checking a condition, and then I have an unbound input value that the solver can then go and try and instantiate to cause an error. And so it'll run this unit test, and you see it takes about a half a second for each test, and most tests pass, and of course I have one that fails because it's good for a demo, and you can see it actually generates the concrete input that a developer could go debug. And we're not doing anything clever here, we're just doing the naive, like if you're going to tell a grad student, here's, in a class, like here's how encoding to SMT logic works, you do it, no fanciness, and it's actually very efficient. Some folks at Morgan Stanley thought this was pretty cool. They gave us a couple of examples that they use for their internal tech demos about some trading applications, and we're like, here are some properties we'd like to check, and we could do the same thing there. I talk about this a little bit in the paper for folks that are interested. But this scales up quite easily to thousands and thousands of lines of code. So that was cool from a symbolic analysis standpoint. Maybe for AI, like can we build better AI programming development environments using this sort of approach? Does it help this as well? So here's an example. I just have a function, find max pair. This is like you do with Copilot today. Give it a little comment about what it's supposed to do, write the signature, ask it to come up with a solution, and it comes up with this, which is, it's in the right direction, but for some reason it's not doing the max of the pair. It's just taking the max of the first element and returning the pair that corresponds to. So, not quite right, not super far off, but as I was mentioning, one of the great things is in Bosque, we make it really easy to explicitly put your intent around in the code. So we support things like you can have an example that's a part of the function signature. And you can go and put in this ensures clause that tells you what the output should be. Now, ChatGPT doesn't understand the semantics of these, but it sees them in the text. And so it can key off of these, and if you ask it now, what is the answer? Well, it comes up with a max of each list, which is not quite right as you see according to the test, but is much closer to what you would want. So now we can go, and since we have these things in here, we can not only use them to key off and try and generate a good example initially, but we can loop back around and say, hey, let me give you some feedback. This fails on this input, right? Can you come up with a fix to this code that will come up with a better result? And then, yeah, it'll iterate around and it'll come up with the correct result or the desired result there. So I think this is a good example of it actually improving what you can do with the AI system as well. Now, one of the things that you might ask is, well, developers hate writing tests, right? They're like the worst, and I hate writing tests too. So, do we really want to go and hand type in like what our inputs are and what the right outputs are, and we do a terrible job? So I'm going to refer back to a very fun paper that I really like called Liberating the Programmer with Probed Programming from Onward 2012, one of my favorites. I've always wanted to do this. So as you notice, I had a keyword defer there. And this is kind of fun because what it does is it allows me to just start running the code without actually filling in the function body at all. And so you can see I have calls to this method here. It has no implementation. And so what I'll do is I'll start, fire this up, and I'll run my video. I'll fire this up. It'll start running, and when it hits that bit of code, it'll pop open a window and say, I got this as the input. Can you give me the correct output? So we can type that in and let it go, and it'll run using that output. And it memoizes it, so it'll reuse it if it hits it with the same output. I get a different input, and I will tell it what the answer is. It'll continue running. And then at the end, it'll basically put all these input-output pairs into a list in a file that I can then integrate back in. So this is the chance for me to go and actually start thinking about writing code, not so much as a developer typing stuff into the application, but I'm sort of orchestrating like what's the high-level structure of the code. I'm going to start running it, start experimenting with it, start gathering basically these requirements, like I'm live requirement gathering, and I can then start feeding these back in a rich sort of multimodal way, examples, constraints, natural language, into this programming language that allows me to express them in a rich way, and that an AI coding agent can go and then consume and generate the code for me. So I become less of a really fast typist and more as sort of a curator of all of these input sources and trying to really build the logic of the application. So, I think this is really cool. So I want to, onward, what's next? Well, I think this is a real paradigm shift from thinking about programming languages as a bag of features that is used for me to type code into to accomplish something, and towards programming languages becoming a substrate for the entire development stack and the basis of communication between many, many parties, humans, automated tools, AI agents, and then you think even frameworks and sort of these microservice architectures, right? It's not about input, it's about communication and collaboration. The key insight, if you take away one thing from my approach, it was, simplify. I'm not trying to be clever and build new things. I'm just trying to focus on solving the particular problem at hand and really create a simple core to work with. And I think there are huge implications. Hopefully the couple of prototypes I showed you, like the goal isn't to build a whole new system, but just show the viability of this approach. But I think there are huge implications for the kind of work we do in building tools, in supporting developers, and driving how software is developed overall. And I'm going to say, even with this prototypes, like I've had to tell people, don't start building anything on this because we're still working on it and we'll yank the rug out from under you. I've had to push people back, but there's extensive industrial interest in this. There's hit a real chord with a number of people who really want to get on board with this. So that takes me to some links and opportunities. There's our GitHub repo. It's not too exciting right now. It's just basically trying to take a bunch of prototype bits and start assembling it into something that we can go actually give to production developers and ask them, you can start building something on this and we're not going to yank the rug out from under you. And I have people in fintech, startups, big tech partners that are hungry to start using this. So if you see something in your research and you're like, I'd like to be a part of this, I'd like to work with some industrial partners, I'd love to talk to you about that because I have way more interest than I can support. I'm also going to do a quick plug. I just am starting as faculty at the University of Kentucky. Very excited to be moving back into academia. So I am looking for good grad students. If anybody has anybody who would like to work on this, I'd love to hear from them. And our department is also hiring again this year. I thought it was a great department to join, so I'd encourage you to take a look at it as well. All right, and I think that is what I've got. So I'm happy to take any questions now, offline, or if you think it's a terrible idea, you can yell at me too.
So we do have time for questions.
Thank you very much for your presentation. We saw a number of presentations this week in which the idea was presented of having some core language which has multiple front ends for programmers, users with different kind of background or different kind of experiences. For example, localized languages of the keynote this morning, but also maybe widgets in projectional editors. But in some sense, your language seems to be going in a different direction by having a particular concrete syntax that maybe different AI or experienced developers share. So do you think this idea is compatible with your motivation and the work that you're doing and could perhaps contribute?
Yes, I absolutely think so. So a funny story. So one of these industrial partners specifically, they came and talked to me. They were interested in the surface language, and I said, you don't want to start building something on that yet because it's going to change. And I mean, let's do a few prototypes. Let's experiment. I'd love to get your feedback, but I don't want you to take a dependency on that. But they did have another language internally. There was actually a different front end, but it was compatible with the requirements to map nicely to that core IR. So we could actually take that, compile that to that core IR, and do the formal validation on their source language as well. So, I think there are two parts to this. One is, what are some of these anti-features? And I think that's an interesting thing from a language design standpoint. And if you want to have a language that does not have some of these, you can map this down to the core pretty well. And then I think the second part is, well, maybe I pick a different surface syntax because I'm targeting, rather than a full citizen developer audience, I'm targeting more of a, an enterprise developer to expert developer audience. And that's just, what kind of user set are you catering to? So I think at the end, yes, I think there are areas where they're compatible. Yeah, definitely.
Hi, Ed Nutting from Vipercore. I'm going to ask a sort of industrially motivated question, which is, languages like this could be very powerful, very useful. How do we, or what's your view on how they would capture the API to existing code bases in other languages?
So this is one of the areas that is really interesting. And I think the rise of microservices and clouds have done a great job, because 10 years ago it was, well, look, Java has a huge code base and you'll never displace them. So what do? Well, people have started to move them not by rewriting those, but by putting, RESTful APIs in front of them and then communicating across those. So I think the ability here, the interest here is, tying into that ecosystem and leveraging, not trying to replace a huge legacy app, but fill in these gaps and then operate in this microservice space. If that answers your question, I don't know if I got a little astray. Okay. Okay, thank you.
And last question, sorry, Marco.
Oh, no
Lucas
problem.
over there. Thank you.
Yeah, thank you very much. Very interesting presentation. Yeah, definitely something I'd kind of been thinking about for a while as we have large language models for writing code that somebody should look into designing languages to work better with large language models. And this seems like you've gone and done that to some extent. I'm wondering, large language models, you need to train them on a ton of code in a particular language in order to actually get good performance. And obviously, if you're starting out with inventing a new language, you don't have a whole bunch of code on GitHub that you can train on. Have you given any thought to that, like how bootstrapping to?
Yeah, I mean, so there's a couple things. Large language models are good at learning generally how things look. And the convenient thing for me is that Bosque looks an awful lot like TypeScript or C#. So even without any real training, it's able to look at it and say, oh, okay, you want something that has like, link-like syntax and has TypeScript-like functions. I know what that should look like. So it's pretty good at generating that. And then on other stuff you can do, in the prompting, they're pretty good at fine-tuning a little bit with, a few shot training just to get it in the right mindset. But that has not, this is an open question, I think, and I think this is an open question in the larger scale. But for me, it hasn't been a big problem yet.
Okay. Yeah, that's what I was wondering if it was through few-shot learning. It is impressive how well LLMs can do it. Few-shot learning a new language, but
Yeah.
that only gets you a certain.
Especially if it looks
distance.
like something it's seen a lot of before, right? All right.
All right, thank you.